Carl Skinner is a name synonymous with firefighting and forest management in the United States. He began his career as a firefighter in Lassen County in 1968 and went on to become one of the most respected and accomplished scientists in his field. After an illustrious career spanning 42 years with the U.S. Forest Service, Carl retired in 2014, leaving behind a legacy that continues to inspire those who work in the field of fire science today. Carl Skinner's contributions to the field of fire science are numerous and far-reaching. He is particularly interested in the interplay between fire and climate, and his research in this area has helped to shape our understanding of how wildfires behave and how best to manage them. His work has been instrumental in the development of fire management strategies that are both effective and environmentally sustainable.
Well, hi, I'm Carl Skinner, and I'm a retired research geographer. I worked a number of years with the U.S. Forest Service doing work on fire ecology, management, and so forth. And so what I'm here to talk about today is this idea, what are the basic principles of fuels treatments? And because there's a whole lot of different ways you can talk about it, this is going to emphasize the stand scale. It's kind of like the localized area, and it's based on a paper that Jim Agee and I published in 2005, which was a very well received paper worldwide. So I thought I would use that as the framework for this talk. And the first thing I want to talk about here is, from the stand scale, is that each of these is kind of a different situation. This is in a place called the Beaver Creek Pinery in the Ishi Wilderness. It's up in the mountains out of Chico. And so what you see is all these different kinds of conditions. It's all within about a 600-acre area. And it's also an area that is frequently burned by wildfires. And the most frequently burned area that we found up and down the Sierra Cascades and doing studies of that. And so this is kind of the scale that I'll be talking about. Kind of like your backyard or the neighbor's place. So, stand structure. For one thing, what we know that's happened that is important from a fire hazard point of view is how stands have changed over the last 100 years or so since we started doing fire exclusion, attempting to do fire exclusion, doing fire suppression. And we started out with places that looked often like this. This is at the Blacks Mountain Experimental Forest. And you can see evidence of past fires down here, but these trees are hundreds of years old at this point. And the fires went through here about every 8 years or so. But these places have changed, and this is what it looks like in the 1990s. This same forest has changed that much because of removing fire from the forest. And this changes the nature of the fire hazard and what we need to deal with in terms of doing fuels treatments. So here's an example. This is from the area near Bernie of Hatchet Mountain in the 1920s. And you can see how open it is underneath, just light fuel on the forest floor. Large old trees and a few younger trees growing, but not in clumps. And then it changes. And this is 1982. I took this photo because it just seemed like a place to me that was a problem place, but typical of a lot of forests. And yes, we ended up with the fountain fire in 1992. And this is as it approached the Hatchet Mountain Pass. And then the result was this, after the fire had come through. One of the things that's interesting about this, though, is this is as close as I could figure out where I was after the fire to this as I could get. And there was absolutely no way to have a view at this time, and look at the view you have after the fire. But look at this patch of trees down in here. One of the things that's interesting about that it survived and not much of the rest of the landscape did, was that area was an area around a family's home and their barn and a few other buildings that they had, and they did their fire safe practices around their home. And so even though this fire came through doing all of this to much of the landscape around it, their place actually survived the fire. And I found that very interesting. So, priorities for fuels assessments. at the stand scale is what we're working on here. Number one is the surface fuel. Number two would be the ladder fuels, and I'll define each of these as we go. And then we have the crown fuels, the stuff that's up above in the tops of the trees, the green parts of the trees and so forth. And then the idea of maintaining large fire-resistant trees, if what you want after a fire goes through is still a type of a forest. So, surface fuels. These are the vegetative material on the ground: leaf litter, dead wood, grass, forbs, wildflowers, small shrubs, basically the stuff that you step on or over when you're walking through a stand. Those are the surface fuels. And surface fuels, the condition of them often drive the overall fire behavior. This is where fires start, they begin to spread, and they build up enough energy to be able to actually move into other layers of the stands. And the surface fire intensity often, in turn, often drives the primary fire effects. What are the effects on the soil? What are the effects on the vegetation as a whole? In terms of what dies, what doesn't die, so forth. And so the surface fuels often are very key to these things happening. And so here's an example of where people have come through and thinned this forest, thinking that will bring the fire hazard down a bit, and it probably will bring it down a bit, but did not do anything with the surface fuels. They left the surface fuels in place afterwards. It's cheaper that way. And so this is what I mean by the stuff that you can walk on or step over when you're going through the stands. Here's a different place, though, where people thinned and followed it with a prescribed burn, and that way they were able to deal with an awful lot of the dead woody material that was underneath and give us light fuels of mostly needles and grass in the understory. And what's interesting is to see how these kind of places react to a fire. Here's the first one that was just thinned. And the fire came through. This was a fire in the Blacks Mountain Experimental Forest. All of these pictures are from there. And it was a north wind event, very low humidities. And the fires went into this stand that had been thinned, but nothing had been done with the surface fuels. And essentially what you see is most of the trees are scorched. Only a few of them have any green left on them, and the stand is largely lost after this fire had gone through. It did make it easier for the fire crews to eventually catch it on the edge, but it's still pretty much lost. Well, here is what the stand looked like where the surface fuels had been dealt with and had been just turned into the light fuels. And so you see most of the trees in here survive with just a little bit of scorch in the lower limbs. And that's kind of what you're after, of what you want as a forest after the fire goes through. So those are surface fuels. Now ladder fuels. Ladder fuels are mostly woody shrubs and smaller trees that are in the understory. And what the ladder fuels do is they provide the avenue for fires to move from the ground up. And that's why they're called ladder fuels. They serve as a ladder for the fire. And so here's an example of changes in ladder fuels. This is from Lassen Park, and this is early 20th century. In the early 20th century, it's interesting that they had the foresight to have crews go to every section corner, every square mile, the corner of every square mile throughout Lassen Park, put in plots, describe the vegetation, and take measurements of the trees and so forth for posterity. This is what Lassen Park was when we first set it up. And then a colleague of mine, Alan Taylor, got the contract to go back in the 1990s and go to every one of those points and take photographs to document how those places may or may not have changed. And this is the same place in 1992. And it shows you actually it's hard to do, but you can pick out the trees even in it that are the same ones that are still left. And it shows you how much now we have a lot of ladder fuels in there, whereas there wasn't much in this. And you had the crowns up here, you have the surface down here, and not a lot of stuff in between to carry fire up into the crown. And now we've got lots of it. And so what's interesting is that these kinds of forests, like this was back in the Beaver Creek Pinery again now, because this area had actually burned twice in the previous 8 years before I took this photo in large wildfires. But you can see that it's open, just light fuels on the ground, and the stands survived. And you can even see the people down here. And here's what they turn into if you remove fire. And this is more typical of places that have frequent fires of low intensity. And this is more typical of places that have infrequent fires of high intensity. This would be more like in parts of Canada or more moist parts of the Northwest. And so when these places burn, they have a tendency to burn like this. And when the other places burn over here, they tend to burn like this. And there's a very difference in the intensity of the fires and in the overall effects of the fires and how much of the forest survives. So what I want to show here is what happened after we had done some treatments in the Blacks Mountain Experimental Forest and the cone fire came through in 2002. It was blown by north winds. This is north up this direction, and it came in the direction this way at us. And you can see places here that had not had any thinning or any fuels treatment work. And you can see lots of white ash in there from the heat. This area was actually on private land, and they had beetles go through and kill a lot of it, and so they logged it all and then replanted. And of course, after this fire went through, they had to replant again. And then here, we did thinning, and it was followed by prescribed fire. And then this part down here was thinned in the early 1980s, but no follow-up fuels treatment. But it was quite a while because this fire was in 2002, so a lot of the surface fuels have probably decomposed by then. And so what I did was I went to the edge of the burn, stood on the edge, took a picture in the direction that the fire came from, and then I turned around and took a picture in the direction into this area that we had already done the fuels treatments to. So this back-to-back photos, this is where the fire came from. This is the stand that was outside. You can see there's no green left in there. It's pretty much everything's dead. And just turned around, standing in the same place, just turned around 180 degrees, and there's what I saw on the other side of where we did the treatments. It was amazingly dramatic to see this kind of a result from doing this work. Crown fuels. Now that's the upper parts of the trees, and up in here, the green part. And crown fuels in California, it's interesting because independent or active crown fires are actually fairly rare in California. Crown fires are normally or usually supported by the surface ladder fuel complex, building enough heat to be able to push the fire up. And then thus they are generally what we call passive crown fires rather than active. An active crown fire is if the fire just gets up in the crowns and goes and it doesn't matter what the surface fuels are doing. And passive crown fire needs the surface fuels to keep it up there. And in California, that's generally the case. And so in a stand like this, you see lots of open area between a lot of the crowns and openings under here. And it basically takes the fire on the surface down here, and with a few of these ladder fuels, torches, to be able to bring the fire up into the crowns. But it's not going to continue as a crown fire in a place like this. It has to be supported by the underneath. And look at this. This is an oak stand, a black oak stand in the Beaver Creek Pinery, right on the edge of the pinery where it came really hard up out of the canyon at it, and it came into the oak stand, and the oaks don't basically carry crown fires very well at all anyway. And so you see it just drops to the ground here and makes its way through. Now here's a place, like I showed you, where we had done thinning and then followed it up with prescribed fire to deal with the surface fuel. And then when the fire came through, that cone fire, this was the result. You can see the char, the char down here, but the trees are still alive and green is what we ended up with, which is what we were planning on happening, and it worked. Now, another thing that's important is to maintain large fire-resistant trees if what you want is some kind of a forest after the fire goes through. And large fire-resistant trees are more likely to survive a fire of any given intensity than small trees that are less resistant, given that they're in even the equal condition of health. There's a big tree. That's a incense cedar. We have lots of those here. It's interesting to know this is in Mexico. And so I just thought I'd throw this in because it's kind of funny that here I am taking a picture of the big tree with a few people down here, and all of a sudden they start pointing up into the sky. And what was kind of cool was that there was actually a flock of condors going over, and that's what they're pointing at. But large fire-resistant trees are deciduous oaks, like California black oak, blue oaks, and valley oaks especially. These three are very good at not generating crown fires, and they also resist fire very well. They don't carry crown fires. And then the conifers that we're familiar with in a lot of our forests are Douglas fir, ponderosa pine, Jeffrey pine, incense cedar, and sugar pine, kind of in that order for how resistant they are of fire. It is interesting, though, that all the fire history studies that we've done in Northern California, in almost every case where we have incense cedar, they turn out to be the oldest trees on the site. Much older than any of the others here. Now here's a way to think about this. Here we have a stand of old trees with young trees coming up under it. So it's got the ladder fuels in there. And here's a stand with only young trees. For some reason, you know, maybe they've been logged, maybe there was a fire went through long before and this was the new stand coming up. There's all kinds of reasons why there's only young trees. Maybe it was a meadow before and now it's being encroached by trees. It's hard to say, but anyway, you end up with only young trees. And then, let's say we have a fire, a low intensity fire, less than 4-foot flames. And in the stand with large trees and mostly young trees underneath, a low intensity fire will often kill a lot of the young trees, but the big trees survive that. But let's say the same fire goes through this stand and it'll end up killing the same trees. And so because we didn't have the large trees here, they were already removed for whatever reason, and all there was small trees left behind, then you end up not having a forest. You got to start over again. Now, why deciduous oaks? I like to talk about oaks because there are so many of them around the valley here and where a lot of people live here in Shasta County and so forth, Northern California. And you can see the structure of their crowns. They're wide open. They don't have a dense foliage, usually, the deciduous oaks. And so they don't carry crown fires very well at all. And then there's the example that I showed you before of an oak stand in the Beaver Creek Pinery that had dealt with several fires. But the other thing that's really nice about oaks is that they do this. If for some reason the upper part does die, the tree isn't dead. They sprout. And what you see here are 4 sprouts from what was the original tree, the original stump that was there, which has rotted away, and now you have these 4 main stems of this tree. And so with oaks, one of the things that's nice about it is that even if 1 or 2 here or there might die in the stand, you don't have to replant. They often will re-sprout from the roots that survive the fires. Conifers don't do that except for a couple of species, and they're not very common in California. And here's also why deciduous oaks, it's easy to put prescribed fires into them. You can do it in winter because they lose their leaves. The sun can get to the ground in the winter, and you can carry fire there when it won't carry in other places very easily. And so with this place, that's a winter burn. This is around Shasta Lake. And then this is the result after spring comes, is you end up with a stand like this, that you change it from looking like this, where lots of stuff is growing up in there, densifying it, and you open it back up again. And then the other thing that's kind of interesting about oaks is that they can do this. See all the leaves here on the ground. And one of the things that's interesting about the oaks is that after a fire goes through, and this is following the high fire that was in 1999 up around on the north side of Mount Shasta, north and west side of Shasta Lake. And this is up on the Backbone Ridge. And you can see the char from the fire that went through. And these oaks have survived. And one of the ways that you know they've survived, they're losing their leaves. If the tree is killed, or if certain branches are scorched and killed, the leaves will hang on the trees. But if they have survived, even if the leaves were scorched or not scorched, when fall comes, they lose their leaves, just like they normally would. And so that's how you can tell that this stand has largely survived that fire that went through there. So priorities for fuels assessment at the stand scale are surface fuels, ladder fuels, crown fuels, and maintaining large fire-resistant trees. In that order, pretty much. Actually, you can put this in anywhere, but it's basically, when you look at a stand to assess it for fire hazard, you start from the ground and you work your way up. You don't start from the sky and work your way down. A lot of people, because the large trees are so beautiful, that's what they think to look at first in terms of fire hazard. But the hazard is actually closer to the ground. And so start low and work your way up. So, cone fire. I want to show you the range of effects that we had. And so here we have no treatment at all in this area. Here's where we had thinning, but we didn't do anything with the surface fuels. And there's where we thinned and dealt with the surface fuels. It makes a big difference as to how the forests survive fire. So the job isn't finished until all the layers are dealt with. And thank you.